So this is example problem D on page 3 of your chapter 28 lecture notes. So we have two conducting wires that are parallel to each other, orientated in the x direction. So we have two parallel wires here. And we're saying that wire 1 is going to exert a force, so a magnetic force, on wire 2. And we're given force per length as equaling 3 times 10 to the minus 4 newtons per meter. So be careful of the difference between force per unit length and just a plain force. So make sure that you're checking out the units. So wire 1 has a current of 2 amps, and then we find out the distance between the wires is 3 centimeters. And the wires are attracted to each other. So we want to know what the current through wire 2 is. So we pull up our equation that contains force per unit length, or the equation of a force between parallel conductors. And we can substitute in our given information, so our force per unit length, the constant, the current we're provided, the distance between the two of them, and we can solve for the second current. And you can see my work over on the right hand side, finally figuring out that the current is 22.5 amps. In part B, we want to know if wire 2 is in the opposite or same direction as the current in wire 1. And that's where the fact that the wires attract come in. So if the wires are in the same direction, they attract to each other. So that tells us that the answer is that they are in the same direction because they are attracted to each other.